Hey guys! Today we'll be introducing combined and joint variation. This tutorial is made by Sofia Castellanos and Gabriela Paez. Joint variation is when one quantity varies directly as two or more independent variables. Keep in mind that it only varies directly but not inversely. Here are three examples of the possibilities of equations you can use to solve joint variation problems, in which y is a dependent variable, k is the constant, and x and z are the independent variables. So the first one is y varies jointly to x and z. The second one is y varies jointly to the square of x and the cube of z. And the last one is y varies jointly to x and the fourth power of z. So here's an example in which they're telling you that the equation is y equals kxz. Now here they're telling you the value of each variable. So y is equal to 45, x is equal to 5, and z is equal to 3. Now what you have to do is replace the variables in your equation. So you'll get 45 equals k times 5 times 3. Now you multiply 5 times 3, so you'll get 15. So your next step of your equation would look like 45 equals k times 15. Now what you have to do is divide 45 by 15 and you'll get that k is equal to 3. So this is how you find k. Here's the word problem that says the volume of a solid with a circular base varies jointly as the height h of the solid and the square of the radius r of the base. If the volume of the solid is 75.4 centimeters squared, the radius is 2 centimeters and the height is 6 centimeters. Find k. Okay, so in order to find k, you need to write the equation, which in this case would be v equals khr squared. And now, just as in the previous example, what you have to do is replace the variables in your equation to get this new equation, that is 75.4 equals k times 6 times 4. Now you multiply 6 by 4, so you'll get 24. So now, in the next step of your equation, you'll get 75.4 equals k times 24. Now, what you have to do is divide 75.4 by 24, and you'll get that k is equal to 3.1416. Now, imagine that you're given this equation, y equals 3.1416 times hr squared. Keep in mind that h and r are both the independent variables, so in order to grab them, you cannot grab them in the same coordinate grid. So you have to first grab the dependent variable with the constant and one of the independent variables, and the next grab, you'll grab the same dependent variable, which is the same constant, but with the other independent variable. So in this case, we're picking h to grab as the independent variable. So the equation would be y equals 3.1416h, which will give us a line, as you can see in the graph at the left. In this other graph, the equation is y equals 3.1416r squared. Look that in this case, the independent variable is r, which gives us a parabola, as you can see in the graph.
Now we're going to talk about combined variations. Combined variation is when both direct and inverse variations occur together in a situation. Some equation examples are y varies directly as xz and inversely as w. The second one is y varies directly as x and the square of z and inversely as w. The third one is y varies directly as the square of x and the cube of z and inversely as w. And the fourth one is y varies directly as the square of x and the fourth power of z and inversely as the sixth power of w. These aren't the only equations that they might give you, but there's some of them. Now let's say in an exam they give you a bunch of tables, and then they ask you to find the combined variation equation for them. What you have to do is first determine whether the table is inverse or direct, and then find the equation. This first one, you can see that is direct because as x increases, y increases also. And the equation is m varies directly as w with a constant of 9. In the second one, you can tell that it's also direct because as x increases, y also increases. And the equation would be m varies directly as the square of t with a constant of 8. Now, for the third table they might give you might be inverse or will be inverse. And you can tell that this is because as x increases, y decreases. And this equation would be m varies inversely as d with a constant of 202. So in that case, you put all these three equations together, and the final equation would be that y, or m in this case, varies directly as w and the square of t, and inversely as d. In these ones, you don't have a constant, or you won't put it there, because all three different graphs have three different constants, so you can't join them. Now, let's say you're given that equation, and now you have to graph. You can't graph that equation in one single graph, so you have to divide it into three different parts. First, what you graph is m varies directly as w with a constant of 9. That will give you a linear equation. That's a linear equation, so it will give you a linear graph. Then you graph m varies directly as the square of t with a constant of 8, and that will give you a parabola. And thirdly, you will graph the inverse variation, would be m varies inversely as d with a constant of 202, which will give you a hyperbola. Remember that you can't join these three graphs. Now let's say that I give you a word problem, which in this case is Mario is pedaling a bike at 80 revolutions per minute using a front gear with 35 teeth and a back gear with 15 teeth. Suppose he is traveling 14.5 miles per hour. Describe how his speed would change if he increased his pedaling to 100 RPM. Now, to find the solution, you would first have to put the equation, which in this case would be S varies directly as RF and inversely as B. And then you have to insert how much the variables are, so it would be 14.5 varies directly as 80 times 35 divided by 15. And the constant would be 0.078. Then you plug in 0.078 for k, and it will give you S equals 0.078 times 100 times 35 divided by 15. So S would give you 18. Then you have to subtract. So 18 minus 14.5 equals 3.5. That's it. I hope you liked the tutorial.
Bye!
Bye!